All right, good morning. Gotta wait a few minutes. What you need, man?
Put this in, like I said, to dispatch.
Mm-hmm.
It's gonna go like that. Like I said, I'm pretty much because it's still up on the manufacturing.
Okay.
It supersedes everything. Once you do that, then it should bring it down.
All right, appreciate you.
Yes, sir.
I'd be safe, man.
Then I think you got service charge fee.
Yes.
Yeah. She's gonna take
I
it.
got you.
Yeah.
You need my card now?
Oh, yes. Sorry. I'll let you put it. I always see the thing in the car. Yeah.
75. Okay.
All right, I guess we got one person. Who's this? Is this you, Jamar, of Memphis? I can't talk, so they have to type it in for me. Oh, okay, man. All right. So what I want you to do, we did some previous problems, the problems I gave you for in the packet. Then we have the review problem. So we're gonna answer any question you may have for that. So I'm going to post the quiz. We could post it tonight, or we may just do it in the morning. But I sent out a reminder. How you doing? All right, so we can start on lesson 21 if you like. Question you may have about that one. If you do not have any question, we could go ahead and start on the practice quiz. Whatever you want to do, just let me know. And good morning. Questions? I can't start until somebody asks me a question. You know what we'll do? We'll start with lesson 21. Four. Okay, I got you, man. All right, I'm gonna go ahead and start 4. If you have some more questions off the packet, we'll get that done. Okay, so if you do number 4, you have f of x is equal to 2, and you have a ceiling. So we're doing integers. All right. So basically what you want to do, you want to come here, and this is, and it's integer. So this is your ceiling function. Or you could call it, or your, make sure I said this correctly. Yep. Your least integer function. Okay, so this right here is your y value. Okay. So what you want to do, all your answers have to be in integers. Okay, so we'll do this. So we'll do. So what you want to do, you want to plug in 0. So if I plug in 0 in here, it's your ceiling. So the answer have to be 0. Then you're gonna go back, just since this is 1 in here, you're gonna go back 1 and you're gonna open it. Now, if I choose a -1, I have to go down to here. So with this y is 2. So normally I would just go down by 1, but now I have to go down by 2 each time. Because this right here is your vertical stretch. So your y is going to be twice as big. Then I'm going to go back 1 because this is just 1x. I'm going to open it. So all the integers between -2 and -1 is going to be, well, greater than -2 up to -1. It has to be integer. That's why they call it integer function. All your answers have to be in integers. Now, then, so if I'm doing greater than 1, greater than -1, up to 0, everything in between there has to be an integer solution. So that integer solution is going to be 0. Now, so if I plug in 1 in here, that means I have to go 1 space over. Okay, but when I plug in 1, this is 2, so I have to go up to 2. Since this is closed at 0, I'm going to open up here at 2. So in other words, when I plug, so every value between greater than 0 up to equal 1, that's all my integer solutions. So every answer that I have, my y's, they all have to be integer values. Okay, so now if I go with one more spot for x, I'm gonna go here, but I have to go up 2. I'm gonna go here, and I'm gonna open up here. Because what it's telling you that ceiling the ceiling, you can't go any higher than that. So you have, oh, this should be closed. Sorry. So if I'm doing this one, if I'm looking for 0, if I plug in 0 for x, that's 0, then I got to go back 1, but I can't include this because this is the answer for this. And that's your step function. Good morning, Uncle Charles. Man, you got to read your material, dude. Okay, look. This right here is, we talk about the ceiling. I gave you this work over the weekend. I gave you the packet. This is your ceiling. So they call this integer function. So all your y's have to be in integers. Okay, so this can't be closed here and closed here at the same time. It can't be closed because you can't have a solution 0, 0 or a solution 0, 2 at the same time. So it's open. All right. So number 1. All right, so we did number 4. Just remember again, number 4, you're going in increments of 1 to the right or to the left. Then this is your solution. So when you have this ceiling function, which you need to read on first page on your packet on lesson 21, which explains it to you. Okay. So whatever, you're going up by 1 in the x direction, but your y is going to be double each time. All right. So let me erase that and I'm going to go back to 1. All right. So 1. So if you're looking at 1, all you're doing is talking about your domain and talking about your range and talking about your y-intercept. We've been doing that since school started. And you're doing it in your previous classes. All right, now, if you're looking at number 1, I'm not going to draw the graph. I'm just explaining to you. So we got f of x, and we have g of x, right? We're going to talk about the different parts of it. All right. So we're going to talk about the domain. So the domain is just simply x values. So if you have your graph in front of you, your domain, if you look here for number 1, for the people that do not have your packet, if we look, number one is the absolute value. So in other words, for number 1, you have every x, you have a y for every x. Okay, so that's going to be all reals. So I'm going to write it 3 different ways. You could do for negative infinity, so positive infinity, or you can say, write the word all real numbers. All right, that's the symbol for numbers, but I write it out. So that means all real numbers mean every x has a solution. You can plug it in all your x's, you're gonna have a solution. Now, I wrote it the other day. And I wrote it before we went to when we was actually in class. This is the symbol for real numbers. So you can write it this way, or this way. All of them mean the exact same thing. All right, so now if we look at, so they asked us to look at the end behaviors. Okay, so if we're looking at f of x, it looks like this, right? All right, so looking for the end behaviors, so we said as xx goes to a positive infinity, as it goes to the right, isn't this going up to positive infinity? So f of x goes to positive infinity. Now, as x goes to negative infinity, we know as x goes to the left, f of x is also still going up to positive infinity. Now, then it asks you for the intercepts. Okay, so if I'm looking at f of x, the function, my x-intercept is going to intercept cross the x-axis, what, twice? So it's going to cross it at where? What's that? -4. And what's that? -2. Or you can simply write x is equal to -4, x is equal to -2. Now we got to talk about your y-intercepts. Where does the function cross the y-axis? So across the y-axis at 0, 0, 2, or you can simply just say y is equal to 2. All right. All right, then, good morning. So, sister number 1. Okay, so this is what you should write for your f of x. So g of x looks like this, since it has an asymptote. So we're going to do the domain. Okay, the domain, also for your domain, you're gonna have a answer for each time you plug in for x, you will get a y. So your domain is going to be the same thing, -infinity, +infinity, which is going to be all reals, or you can write this symbol. When you take pre-calc and you take calculus, you're not going to be writing this anymore. These two things here, you're going to be writing this symbol here for all reals. So you need to know it now. Okay. All right. So you're basically going to say the same thing. All right. So now we're going to look as x goes to +infinity, g of x is going to go, if you look, as it goes to the right, it's going up, right? So it goes to +infinity. All right, now, as x goes to -infinity, as x goes to the left, if you look on your pack and look up here, it's approaching a point. So this is going to has an asymptote. Okay, so that means g of x is only going to go so low. So it's going to approach, if we look at that, that's what? That's -2, isn't it? Yep. So it's going to approach -2. So this right here is your asymptote. And we should know what asymptotes are. You're going to see asymptotes for every math class that you take from this day forward. Except for AP Stats. You won't see it in AP Stats. All right, now, but you'll see when you take college calculus-based statistics with, you'll see asymptotes. All right, now, so we have to do our x-intercepts, don't we? Okay, so we have our x-intercept. Then we're going to write an order pair, or we can write it like this. Either one is correct. Or you put an or here as well. Okay, so looking at the function, the exponential function, we have x-intercept is what? 1, 0. Or we can just say x equals 1. Then the y-intercept, it crosses the y-axis where? At -1. Or we could just say y is equal to 1, -1. So that's number 4. And you have to know how to do this, especially when you take Ms. Garcia next year. Well, I hope everybody's being safe, but to be honest with you, class, I don't think I'm going to see you all until next year. So I think we're going to finish this class up online. So please be here every day. Tell your friends to be here every day, because I have 35 students and we only have 7. Okay, so we do have to do these tests and quizzes, because with the way this thing is spreading, I doubt very seriously we're coming back to school. I will be shocked. Okay, so please encourage your friends to come online and they response for these tests. Okay. All right, now, so do we have any questions on lesson 21? So we're good on the rest of them? If not, we can go start the practice quiz. I'll give you a few minutes to type in. If not, we'll just go to the practice questions. Hey, don't forget your card over here. We'll get a new fridge. Ah, that's okay. Huh? So you want to go buy one today? Okay. All right. So, no questions. So you understand the answer key that I put on the blog for lesson 21. Oh, somebody said number 8. Okay, I got you, Crystal. Of course. All right. All right. So I'm gonna go ahead and erase this. Okay, so Cameron kicks a rubber ball straight at the concrete wall. Okay, it bounces against the wall and rolled back to her. Okay, so the distance between Cameron and the ball is given by this. So basically, what you're doing, Crystal. So you have here. Okay, so basically, what you want to do here, Crystal, is I would do this. This is absolute value problem. All right. So if you look at here, we're going to find the vertex. So basically what you want to do is say to yourself, what's going to make this 0? So what you want to do here. All right, so we know if you plug in here, that's could be, we could put t equals 5, right? So I'm going to put t equals 5 here. So this is t, and this is d of t. All right, so if I plug in 5 here, so that's a -2, absolute value of 5 minus 5 plus 10. So this is going to give me 0. So that's 10. So that's going to be basically the maximum height from the wall. So 5, it's going to be here. Okay, now after that, so this will be considered if it hits the wall based on the equation they give you. Okay, so we know if we plug in 0 here, if I plug in 0 here, I'm going to do, so a -2, absolute value 0 minus 5 plus 10, that's going to give me a -10 plus 10, which is going to give me 0. So if I start 0 here, and that's going to be time in seconds. Then if I go over here, I put 10 in here. So that's going to give me a -10. 10 minus 5 plus 10. So that's giving me a -10 absolute value of 5 plus 10, which is also going to give me 0. So since this is the absolute value function, it has to have the absolute value. It has to be a look like absolute value. So, all right. So you can't go, remember, we can't go in negative seconds. Okay, so we put restrictions on it. So the smallest time we have is 0. And then if this is 0 and you're saying to yourself, when will it come back to her? So to come back to her back here, and this is your y direction, and this is 0. And so she'll get it back in approximately 10 seconds. So that's your graph. So the question asks you how far is camera from the wall? So when you did this, it's basically told you what it was going to be when you set this equal to 0, because this is going to be a maximum height or your maximum height, your minimum height. But since this is negative, it has to be a maximum height. Because normally when you do a absolute value, if this was positive, it will have this will be the minimum point. But this right here is your max. If you think about it, it's kind of like the quadratic formula. Remember I told you this is your A value. If it's negative, that means you have a frown on your face, so that's your max. If it's positive, you got a smile, so that's the minimum. So since this is a -2, that's your maximum height. And so that's why it looks like that. So basically, it takes 10 seconds. Is that maximum height at 10 feet? I'm sorry. Maximum height is 10 feet. And for it to get back to 0, get to 0, it's at 0 seconds at 10 seconds. All right, cool. All right, so let's go ahead and start on this review packet. Get ready for the review quiz. So if you get that out, we can look at that one. So I sent out a major quiz practice for you all to do. I know I sent it out last night, but I put the answer key this morning. Okay, so I put it on the blog. So if you, let me see. Hold on for a second. I got to check something. I'll be with you just a second. I'm back. I have to check something. Okay, so the packet I gave you, which question do you have? We can look at that. And I hope this answers your question, Crystal. Oh, and the other people that's on here, I apologize. Got to keep everybody in the loop. All right, now, so now we got to look at the review quiz. And like I said, I'll send it out. I'll send it out tonight. And then I can, I'll try to grade it this afternoon, grade it tonight. I'll probably get up early in the morning, grade it. Give you a chance, give everybody a chance to do it. Number 3 and 4. So that 3 and 4 from the review packet. So that's from the review packet. So we can go ahead and do that one. Oh. Okay, that's good. You're talking to me or just John? All right. So if you want to graph this, so normally, if you had your parent function, it will look like this. All right. So I'm gonna put the parent function, and I'm gonna do the parent function. I'll put it in dashes. Okay. So we're gonna do f of x is equal to the third root of just x. So this is your parent function. All right. So what you want to do for, I guess I'll make it bigger. Okay. So this is, so we're going to do the third root of x. All right. So again, you don't want any fractions if you can help it. So what you want to do is you want to find perfect cubes. So a perfect cube would be -8, because if it's an odd function, you have negative and positive solutions. So a -8. So a -8, all that is the third root of -8 is basically -2. The reason why that is because if you do -2 times -2 times -2, that's going to give you -8. So the third root of -8 is -2. Then if you do -1, the third root of -1 is -1. Of course, we put 0, that's going to be 0. You put 1, that's 1. You put 8, that's going to give you 2. Now, so, but if you do this, g of x, well, let me go ahead and graph. All right. So if we use the parent function, you should get 0, 0, 1, 1, 8, 2. -1, -1, and 8, -2. All right, so that's your parent function. All right, now we have to do the, so now if I was doing this one, I'm basically doing setting is equal to 0. So x is equal to 2. So I'm going over 2 spaces to the right. So I'm basically going to come over here. Instead of this being 0, 0, now it's 2, 0. All right. Instead of this being 1, 1, now it's going to be 3, 1. Now, instead of this being 8, 2, now it's 9, 2. Instead of this being -1, -1, -1, now is 0, -1. So instead of this being, no, I'm sorry, take that back. Yeah, that's right. Okay, if I go here, so I went over 2, it should be 1. Take that back. Okay, so it should be, instead of this being 0, I got to go with 2. Instead of this being -1, it should be 1, -1. All right. Instead of this being -8, now it's -6, because this is your shift 2 spaces to the right. All right. So now your function is the same function. It's just going to be moved 2 spaces over. Okay, so it's here. That's the only difference. You just moved it 2 spaces over. So this went from, no, it should be 10. My bad. It should be 10. Sorry about that. So it should be 10, 2. And then this should be 3. And then this would be 2, -1, -6. So this should be 10, 2. This should be 3, 1. This should be 2, 0. This should be 1, -1. And this should be -6, -2. All right, we'll get to one bonus in a second. Okay, so we got 11. And you have, so we just, we're 11. We just did 3. And we're not, we need to do 4. So that's the graph for number 3. All right. Now, when I made the answer key, I didn't put the parent function on here. Now, some student was saying, do you have to put the parent function? No, you do not have to put the parent function, but everything starts from the parent function. So if you just put this on here, you're fine. But if you just have to need a reference point, you can go ahead and put your parent function on here. Just dot it. Let you know that's just that's not the final answer. This is your final answer. Okay. All right. I don't see anybody, so I'm gonna go ahead and do 4. Let's see. Let's see. I hope that made it a little bit lighter. All right, now. All right, so I'm gonna go ahead and do 4. All right, now 4, you have a quadratic, which is, you should be happy to have a quadratic. Okay, so if they just got a radical by itself, that means you're just taking the second root or something. All right, so we got 1/2 x plus 1. So if you want to see which direction you're going in, I would just, for direction, x-wise, all you have to do is set this equal to 0. So you're -1/2 x plus 1 equals 0. So it's a -1/2 x is equal to a -1. We're going to cross multiply. So we have x is equal to a -1 times a -2. So x is equal to 2. So basically what we're going to do is take the parent function and we're just going to shift it to we're just going to shift it 2 spaces to the right, but we're going to be going in the opposite direction. All right. Parent function normally goes through 0. All right, so if we was doing this, we would come here and put x, that's y. Then, all right, since we got it shifted 2, instead of being 0, we need to start at 2 instead of 0. Because if we do the parent function, all right. So normally if I was doing the parent function, I would start at 0. Okay, so we're going to start at 2. So we have a -1/2 times 2 plus 1. So that's going to give us what? That gives us a -1 plus 1, which is going to give us what? 0. So that'll be here. Now we know we can't put positive. If we was to put positive values in here, we'll get negative answers, right? So we want to use, so what we want to use, so let's plug in 0. So we want whole numbers. So if I plug in 0, that's going to give me a negative 1/2, 0 plus 1, which is just going to give me the square root of 1, which we know that's just what, 1. So 0, 1 here. Now I could have I could have picked 1, but I would have had a fraction. And I don't want a fraction. Okay, I'm trying to keep whole numbers because all I have to do is just graph this. Then whatever the answer for 1 was, it's going to be very close to what's on this line. Okay. Now, again, I want to try to keep some whole numbers. Okay, so I should have went out to. So now I got to go out to. I want this to equal to 1. So in order for that to equal to 1, I need to make this negative 2, right? So I'm gonna plug in negative 2 here. So that will give me no, I don't want to use that. I want to use negative 2. So what can I plug in to make this equal to I got 1. So next thing I need to do 4, don't I? So in order that to be 4, I need to use a negative 6, don't I? So if I use a negative 6 here, so a negative 1/2 times a negative 6 plus 1, that's going to give me what, 3 plus 1, which is going to give me what, 4, which is going to give me 2, right? All right, so I need to erase this. And I'll rewrite it. Okay, so I need to go out to negative 6. So negative 3, negative 4, negative 5, negative 6. So if I go out to negative 6, that's going to give me 2, right? So that's my graph. So when I plug in this negative, it's telling me I have to go in I'm going to be going this way because the only way this is going to be, the values up on the route is going to be positive only if I make these negative answers. So it has to, so since I have to plug in negative answer in order for this to be a real answer, a real solution, not imaginary, I have to use negative numbers. And so that's the answer. That's number 4. Okay. All right. So we'll come back to that one, Grace. I'll take care of it. Okay, so negative 1/2, that's in the problem. If I was to plug in, if I plug this in here, this is the question. So if I plug in, say 2. So if I plug in, so I got a negative 1/2, because negative 1/2 that's the original problem, is a negative 1/2. So if I do a negative 1/2, I put 2 in here, that's going to be plus 1. Then that's a negative 1 plus 1, which is 0. So the ordered pair is 2, 0. If I plug in 0 here, that's a negative 1/2 times 0 plus 1. That's going to give me what? 1. Then now, if I do the square root of that, that's 1. So therefore, I have 0, 1. Then if I want to find out, so I know that my y is 1. So how can I get the square root of 4 up under here? Okay, so I'm going to do the square root of a -1/2 times, I know this is +1, so don't I need a -6 here to make that 3? So then that'll be 3 plus 1, and that's the square root of 4, and that's going to give me 2. So my solution is a -2, -6, 2. And that's where this comes from. The original problem is a -1/2 x plus 1 up on the radical. So Jamar, I hope that answers your question. Where the -1/2 come from, that's the original problem. Because if I were to plug in numbers bigger than 2 in here, this is going to be a negative. So if I plug in 3 in here, that's a -1.5. A -1.5 plus 1, you can't do the square of a negative number. So you got to go in this direction to get positive values. And again, a -1/2 is in the problem in the very beginning. Good. All right, now. All right. So we had 1, the bonus. Did we do 11? All right. So let's look at 11. All right, so this is absolute value problem. So what you want to do here, set to yourself what's going to make this equal to 0. So you do 3x plus 3 equals to 0. So that's 3x is equal to -3. So x is -1. So this is your center, or you can say your vertex. Well, I don't want to get you confused. So this is your center of the absolute value. All right. So what that means is we're going to come here, just like a quadratic, we need a couple points. But we got, this is the center. So we're going to go 1, 2, 3, and we're going to let this equals -1. Then we'll put -2, -3, -4, 0, and 1. So what we're going to do now is we can plug in points. Okay, so set this equal to 0 to find out where your center is. Okay, so since this is a +1, this point here, your max is going to occur here. Your max y is occurring at x equals -1. All right, so we can plug in here. We can start in the center. So that's just 3 -1 plus 3 absolute value plus 2. So wouldn't it just give us 0? And so that would be what? Just 2? Because this is 0 plus 3. All right, now we're going to plug in 0 in here. So that's going to be absolute value of 3 times 0 plus 3 plus 2. So that's going to leave us the absolute value of 0 plus 3 plus 2 So we know the absolute value of 3 is 3. So that's going to give us 5. What did I do? So if I use, oh, I'm sorry, this should be the minimum point. Minimum, I bet. So this should be the minimum point because this is positive, so it should be the minimum. I'm sorry. If this was negative, it would be the max. All right, so then this would be 5. Then if I plug in 3 times 1 plus 3 plus 2, so this would be what? So that'll be 6. 6 plus 2 is equal to 8. All right, so if I come here and do the same thing here, I should get 5 and I should get 8 here. All right. All right, so if I plug in 3 times -2 plus 3 plus 2, so then that will give us what? Absolute value of -6 plus 3 plus 2. And so then that's absolute value of -3 plus 2 equals 5. Then I'm going to come here. Well, we'll just do 3. So we're going to do 3 times -3 plus 3 plus 2. So that's going to give us the absolute value of -9 plus 3 plus 2, which is going to give us 6 plus 2, which is 8. So just like the quadratic function, okay, if I go one space in the same direction, equal space in the same direction, I should get the same answer. So this want to be minimum. So all right. So now we're gonna go and just start from, so that'd be 1, 8 and 0, 5. -1, what, 2? Okay, -2, what, 5? -3, 8. And that's your absolute value problem. Okay. All right. So if you did the previous problem, there was a number 11. Okay. So I just put that up anyway, but I can do the bonus. Okay. So is your 13 bonus number 3, Crystal? I figured out what it was, but I didn't want to know. I didn't want to not do this problem, but I figured you were saying bonus number 1. So, but I just put this for just in case. Man, if you don't stop, yes, I'm left-handed. Now, all right, so what I was gonna do, so let me go back and see what question we had to do. Okay, so Grace, you said you had question about number 20, lesson 21. What question did you have? Because I want to go ahead and do these practice quizzes. So go ahead and do that, then we'll finish up these practice quizzes. Grace, waiting on you. And we're gonna keep this. This is less than 21. Grace? You just, if you're doing less than 21, you're just gonna have to pick the values. You're gonna have to pick those values. Okay, if you look at go back and watch the video on the problems I worked on to show you if it's cube, I always try to find perfect cubes, which it's gonna be up on the radical. If you're doing squares, you're gonna look for answers where you have perfect squares up on the radical. And that's gonna be up to you to look at to figure out, okay? Because I'm not just gonna do a problem and I don't want you memorizing the problem. I want you to memorize the method. That's the most important thing that you need to know. Okay. So memorize the problem. That's not going to help you when you want to go to these nice colleges that you plan on going to. So I got to teach the concept. And you're going to have to figure that out on your own because it's only going to help you when you take calculus and when you take pre-calc. Okay. All right. So I'm going to go ahead. Let me go back. And so we needed bonus 1 and bonus number 3. Oh, well, let's go ahead and do 5 for Mark Charles. Help him out. Okay, so we're going to look at problem number 5. So problem number 5, you have f of x is equal to a negative 3 the square root of x. So basically what this is doing, remember, this is going to be your reflection. And this is going to be your vertical stretch. And this is going to be a reflection about the, so let me see. So if I go, yeah, reflection about your x-axis. All right. So what you want to do here again, Grace, if you're looking at this, you want to look for perfect squares. Okay. So if we come here, and I know that I want to have, since this is a square root, I want to have only positive values up on the radical. So the smallest will make this positive is 0. So I have 0. So I have a negative 3 times 0, which is just 0. Then I know the square root of 1 is 1. So I have negative 3 times the square root of 1, which is just negative 3. Then I got to say to myself, what's another perfect square? Well, I know 4 is a perfect square. So I'm going to do a negative 3 times the square root of 4. I know the square root of 4 is equal to 2. So that's a negative 6. All right. So we can just use these 3 points. We just need a couple points to see what the graph is going to look like. All right. So now we could just come over here and graph it. Okay. So we have what? 1, 2, 3, 4. All right, so then we have what? 1, 2, 3, 4, y-axis, x-axis. So we have what? 0, 0. We have, okay, so this right here, this is going to stretch it in the negative direction. Well, take that back. Okay, so this is going to be a vertical stretch, but this is going to be a reflection about the y-axis. So now we have a negative 1, negative 2, negative 3. I should have made some space for this. Let me read. Okay, so we'll adjust. I always adjust. Being a former Marine, I always just adjust. So it's a -2, -4, -6. So that's 0. And then we got 1, so that's -3. All right, so 1, -3, which is right here. Then we have 4, -6, which is right here. So we stretched the 3. So instead of this being 1, 1, instead of this being 1, 1, instead of this being 1, 1, if we had the parent function, this would be 1, 1. Okay, but if we're doing the reflection of it, it should be 1, -1. Okay, but since we multiplied it by 3, now it's 1, -3. Okay, and so and then when we did plugged in 4, normally it would be 4, 2. But since this is a reflection about the x-axis, now we got to flip it here to 4, -2, but we tripled it. So now it's 4, -6. So if you have a negative on the outside of your radical, that's going to be a reflection about the x-axis. If you have a number outside the radical that's bigger than 1, that's a vertical stretch. In other words, it's going to make it 3 times the size it originally would be if it was the parent function. If it was less than 1, it'll be a vertical shrink. All right. All right. So that's number 5 for you, Mark Charles. And I think we're going to do those bonuses. And I think that'll be it because I think that's all the questions that we have. Okay. So let's look at these bonuses so we can keep these high A's, the people that have them. Or for the other ones that you still get your grade up. Okay, I'm making this bonus, but it's not going to be a bonus on the test because you have to know how to do this when you take pre-calc and when you take calculus. So my 9th graders in this class and my 10th graders, okay, you're going to take calculus before you leave high school, okay? Because you got a good grade in my class. Trust me, your parents is going to want you to take it, and it's definitely going to help you when you're in college. Okay, for the juniors, if you want to take calc, you have to double up, or you could just take calc instead of AP statistics, but I strongly recommend that you take AP stats and calc before you leave. Okay, so, all right, so let's erase this so we can go to the bonus problems. All right, so when we do this, when I give you this quiz, I'm going to grade it, and then we'll go over it in the morning, but I have to grade it first. All right, now, so let's look at bonus 1. All right, so we're going to look at bonus number 1. Okay, let me see if anybody has some more questions. Took care of Mark Charles. Okay, so, all right, so we're going to do bonus 1. All right, so what we want to do here, we have 3x minus 3 all over x squared plus x minus what? Minus 2. All right. So remember, the most important thing, you always have to always factor. Okay, so we factor. So this is f of x. You know what? Let me fix this. So we have f of x is equal to 3x minus 3 all over all right. So we always want to test for discontinuity. So remember, discontinuity, we're going to see what they have in common. So we got 3 comma x. If I factor this out, this, and I factor this one, this would be what? X plus 2, x minus 1. All right. So since we have something in common, this is where your discontinuity is going to occur. All right, so remember, we're just going to do what they have in common, set that equal to 0. So x is equal to 1. Now, we got to come here, write the equation. We're going to do f of x is equal to 3 over x plus 2. So this is your new equation or new function. All right, because since we simplified this, we're no longer going to use the original function. All right, so now to find your discontinuity, we're going to do f of 1, which is simply just 1 plus 2. So that's going to give us, so f of 1 is just going to be 3 over 3. So we're going to have a hole in the function. At 1, 1. So now we got to find the horizontal and vertical asymptote. And I put in your notes HA because when you take this in pre-calc and take it in calculus, it's just going to, horizontal asymptote is just going to be capital A, capital H, capital A. All right. So what you want to do, remember, if you have this, since your highest power is on the bottom, we know that we're going to say that y is equal to 0. Remember, we talked about if you're high. So this is degree 1, this is degree 0. So the highest power is on the bottom. Since you don't have anything sitting out here, so since it's just 0, that's your horizontal asymptote. Now, when you take pre-calc and calculus, they're going to put a number. Well, I think we're going to do it toward the end. But if you in your higher math, there's a number back here. All that is going to be is your shift in the y direction. Now, we got to find the vertical asymptote. And remember, your vertical asymptote, you're just going to set this equal to 0. So you're going to take your, so this right here, set is equal to 0. So -2. All right. So now we can start. Whoa, now not whoa, but this is right. I'm just trying to figure out how I'm gonna have some room. So now, if I to graph this. I had to make it a little small because I need some points, some place to put the points. All right, so our horizontal asymptote is going to be 0, right? So what we need to do here, this is your horizontal asymptote. So that means the function will not go above. So this is your horizontal asymptote. And add a little color. Now, so we got the vertical asymptote is -2. All right. So now we're going to pick some points. So we know that at x equals -2, there's no solution, it's undefined. And then at y equals 0 is undefined. So what you want to do is you want to pick a couple of points in this area. Then you want to pick a couple of points. Pick a couple of points on the left side of x equals -2. Then you want to pick a couple of points on the right side of x equals 2. All right. So what we want to do with that one is we're going to plug in. So what did I use? I used -4. All right. So we may have some fractions in this one. Okay. So we're going to plug in -4. So if we plug in -4, so that's going to give us what? 3 divided by a -4 plus 2, which is going to give us 3 over -2, which is a -1.5, right? All right. So we're going to come here, -1.5, 4 -1.5 is about right here. All right. Then we're going to use you want to use -3. So -3. So that's going to be 3 -3 plus 2. So that's a -3. There's 3 divided by -1, which is -3. All right. So we're going to come here. So that's all you need. These 2 points are good. So all you have to do is draw this, because we know it can't cross this line, the x-axis, which is horizontal y equals 0. We know it can't cross the vertical axis with -2. So this is going to be what the graph is going to look like. Now, all right. So now we got to pick some points. So we know if we pick -2, that's going to be undefined. All right, now we just need to pick 2 points on the other side. So we're going to pick -1. So that's going to be 3 over -1 plus 2. So that's going to be 3 over 1. So that's going to be here. Then if you notice, so we're going to use 0. So that's going to be 3 over 0 plus 2, which is a positive 1.5, right? So we're going to go 0, 1.5. And so the looks of it, we know it's going to look like so. It's approaching your x-axis, but it'll never get there. Okay, it's if we go here, if we go to the left, it's going to approach y equals. So it's going to approach, it can't cross this asymptote. So it just has to keep going up and going up, but it'll never cross it. So that's your function. So give you a minute to look at that. Like I said, I wrote all this stuff out. So I'm writing in detail, but I also put it on the blog. Okay, so when you, again, in your high level classes, when you see VA and you see HA, they're talking, when you're graphing, they talk about your horizontal and your vertical asymptote. So we know, remember in class, asymptote that's where the function is going to be undefined. So I think we could do bonus number 2. a 3, or was it just 1 and 3? Let's see. Yeah. So we'll have to look at this. We'll do bonus question number 3, and then we'll be done for the day. Now, keep in mind, I have to teach AP Statistics next. Then I got my AP Statistics review this afternoon. Okay, so give me a few minutes. So you have actually until tomorrow morning to do the quiz. So we do the quiz. So we'll do the quiz. You can do it in the morning, and I'll grade it. And then what I'll do is we're gonna do a review for the whole chapter tomorrow. Then after I do the review with you all, I can put your answers on there for your quiz. I can do that tomorrow evening, but I have to teach 3 classes a day versus 2. All right, but I put the stuff up there for you quiz it, and I'll try to grade it tonight as well, and so I can have it graded. So when people ask me questions, instead of just copying it down, I can actually see what your grade actually was. All right, now, so we're good on this, because I need to go ahead and do that last one, because we're actually going a little over time. All right, so let me go ahead and do the third one. All right, for the third one, we have f of x is equal to 2x plus 1 all over x. No, I'm sorry. That's the second one. Apologize. All right. So for the third one, we have f of x is equal to x squared minus 1 all over x. All right. So remember from class that if your highest power on top, you do not have a horizontal asymptote. So your horizontal asymptote, we can go. Hold on a quick second. Hey, man. I'll teach you right now. Okay, I'll be done in like 5 minutes. I got it. Okay, I'm back. Sorry about that. That was a very important phone call. Okay, now, all right. So horizontal asymptote. Since we know the highest power is on top, we simply it's just gonna be none. So in other words, there's no restrictions in your y directions. Okay, so now what you want to do, if this is your vertical asymptote, so you're gonna set that equal to 0. Oh, first, before I do that, they have nothing, so we gotta look for discontinuity. All right, so for discontinuity, so we have x plus 1, x minus 1, all of x. All right, so they have nothing in common, so there's no discontinuity. And the reason why that is the numerator and denominator they don't have anything in common. So now we got to find the vertical asymptote. So the vertical asymptote, you're just going to set the denominator equals 0. So that means x is just simply equals 0. All right. So in other words, your asymptote is going to be your y-axis. All right. So now we have to plug in some points. Okay, first you're gonna, you have the graph. I have the graph written. You don't have to draw it out. I got you. All right, now, so what we want to do with this one, 1, 2, 3. All right, it's been a hectic morning. The refrigerator went out, so we got to go get a new one. It's brand new. I don't know why it went out, but we got to go take care of that. Now, so what we want to do here, so your vertical asymptote is going to be 0, x equals 0. So basically, you're not going to have any solution where x is equal to 0. All right, so horizontal asymptote, you don't have to worry about that because you're good on your y's. Okay, now, so what we want to do, since we just have a vertical asymptote, we're going to pick a couple points on this side, and we're going to pick up a couple points on this side. Okay, so if you were to pick, so we're going to pick some points. So we can pick, I'm going to pick negatives. We're going to pick -2 and -1. You could pick more if you want to. All right, so this is y, this is -2. So if we look at this right here, so that's a -2 squared. Go back to original problem, since we don't have any discontinuity. Okay, so that's 1. So that's going to be what? 4. 4 minus 1 is 3. So a -2, 3 is right here. All right, then we're going to pick -1. So if we plug in -1, a -1 squared minus 1 is 0. All right. Then if we pick, what did I do? So what did I do? So I did -3. So if I plug in -2 here, so that'll be 3. So if I plug in 0, oh, my bad, I'm sorry. At 0, we have no solutions, right? So my bad. So let me redo this. I apologize. Okay, so if we do this, so we have a -2 squared minus 1 all over -2. And so that'll give us 3 over a -2, which is a -1.5. So that's a -1.5 and -2. And then if I plug in -1, so I have a -1 squared minus 1 all over -1. And then that should give me 0. All right. So basically what you want to do, you can plug some more points in. So, but your graph is basically going to look like this. As you keep going, it's going to approach. It can't cross here. So it's going to look something like this. You can plug in some other points here. Okay, now we know that it's undefined at 0. Now we're going to plug in 1. We can plug in 2. So we plug in 1, that's basically going to give us the same thing here. It's just going to be positive. So let me show you. So if I do 1 squared minus 1 all over 1, so that's going to give me 0, wouldn't it? So because I have 1, 0. All right. So if I plug in 2 in here, that's going to give me 2 squared minus 1 all over 2, which is going to give me 3 over 2, but positive. All right. So then 2 goes, so 2 will give me a -1/2. So the graph is going to look like this. Remember, this is your asymptote, so it's approaching that point but never get there. So that's your graph. Okay, so these are the questions. These are your bonus questions. But I put bonus because we did it like over a week ago. So I made a bonus because I wanted you to go over it again so you can get it. So it'll be a bonus on the quiz, but we have to know it for the test. All right. All right. Well, thank y'all for tuning in. I will see you all tomorrow. If we don't have any more questions, that is going to be it. Okay. So I'll wait a few minutes to see if anyone have any questions. If not, I'm going to go ahead and get ready for my AP Statistics course. This evening, Mark Charles, this evening. I'm going to put it on the blog this evening for you to, well, not on the blog. I'll give you directions because I need for you to send it to me so I can grade it. So no, we're not taking it right now. I'll give you some time to look over this, to make sure you understand it. And sometime this afternoon, I'm going to send it. I'm going to give you directions where to get the quiz, work it out, and send it back to me so I can grade it. You too. All right. See y'all later. Any more questions? All right. Got to take a break and keep it moving. All right. Not a problem, man. I know what you meant. All right. See y'all later.